This printer next to me is the Dancer Mark I. It is a fully custom cross-gantry 3D printer, which I've been working on for around about a year. And for the past few months, I've just been using it, printing parts, making some small tweaks along the way, and just analyzing what changes I'm going to have to make. And as mentioned in my last video, the biggest issue that this machine still has is VFAs. The surface quality of the parts it produces is just not where it needs to be. Now, there are a number of potential causes and contributing factors to VFAs, but in this case, we can generally just say it's because of the design, setup, and tuning of the XY kinematics. Now, to try and solve this issue, I'm going to be installing a new toolhead and new gantries. And if all goes to plan, this should improve our surface quality and the dimensional accuracy that this printer is capable of. But before we can install these new parts, we have to uninstall the old ones. And then I can show you some of the poor design choices I made, which have been, causing my issues. Okay, so before we can get into the actual install and setup of these parts, I thought we should just go over the CAD and look a bit more in detail of what changes have been made. Yeah, so the two primary places where we're making changes are, first of all, the gantries and then the toolhead. Starting with the gantries, I don't have the old version loaded up right now, but I'll put a picture on screen. The way that the belts were fastened into the gantries was suboptimal. I essentially was using channels which you just push the belt through and then clipped off at the end. The problem with that is that it's very hard to control exactly what the length of belt under tension is going to be, meaning that even if you were to cut all your belts to the exact same length, you're going to have a very hard time guaranteeing that all 4 segments of belt have the exact same length under tension. This new version, on the other hand, should solve this. Because instead of there being a channel that you just push belts into, it's actually just I don't know why this is muted out. You're basically just clamping it straight down. Here we have a clip that has the belt's profile in it, and this is just, clamping these down into place on the back of the gantry. It's held in with a few screws, and using these little cutouts here, these little windows, you can see exactly what position the belt is in behind the clip, so that provided that you cut your belts all to the same length, you can guarantee that you have the exact same length of belt under tension for each of the 4 belt loops. Now, generally for these gantries, just stiffness was a problem. On the first version, these were printed out of glass fiber reinforced ABS, which is stiff but not stiff enough. On this next version, I've printed everything out of glass fiber reinforced PPS, which is significantly stiffer than ABS and also has less creep. which was a problem for these. Now, if we just look inside this, um, yeah. Um, now the gantry body is attached to my MGN 15C carriage using just M3 screws. Well, you have to, but I've made a slight change to this. Here you'll see these holes for the M3 screws are actually have a diameter of 5.5 millimeters all the way through, which is obviously too big for, an M3 through hole. But what I'm doing here instead is I'm basically adding an M4 heatset insert into the bottom of the gantry. I'll put a picture on screen so that when I actually do torque down the M3 screws to attach the gantry to the carriage, you're actually torquing down on metal, not directly onto plastic. So theoretically, you're not gonna be losing tension to creep, and it should be a bit stiffer. Um, yeah, so that means that there's a lot of added weight because of all these inserts. Because basically, you have four long M4 inserts for the screws that attach the lid, then you have another four for the M3 screws to go through. And I was a bit space constricted for um, for adding inserts for the screws that are holding the belt clamp in. So what I did is I basically just get out of the way. I basically just added these little square pockets over here, which I then press fits square M3 nuts into, um, which these then which I can then screw into. This just is a little bit more because I was a bit space restricted. I couldn't really fit an M3 heatset insert in here. I could have maybe on the back here, but that's just then I'd be using a very long screw. So I just, yeah, three press fits, um, three different press fit square M3 nuts, and that's what's used to fasten the belt clamp. Yeah. And then, of course, the other gantry is basically the same, just raised up a few millimeters. I didn't make any changes to the motor towers because I just scope creep. I didn't want to make too many changes at once. But I think that the next course of upgrades for this machine will have to be the motor towers. Yeah. Anyway, getting onto the tool head. Actually, I still have the old parts visible here. Hold on, let me just. I guess doesn't want to. Oh gosh. I don't know why it doesn't want me to isolate these. Basically, now I'm annoyed. I guess I'll just have to mute everything else because it doesn't let me right click on that to isolate it. Anyway, this is what the old toolhead looked like. Essentially, you had a main base plate to which all your components would be mounted. And then your two linear bearings, your LM12 LUUs, they had their own housings, which were separate to this base plate that were just screwed in. Now, there's a big problem with this, and that is that there's nothing actually preventing your X and Y axis from getting skewed. There's nothing constraining these to be 90 degrees from one another. So I'm not sure what the best word in English is, but in German it's Rechtwinkligkeit. There's just no constrained Rechtwinkligkeit, I guess perpendicularity. And because of that, if your belt tension isn't properly dialed in, if you just, weren't very good on the setup, if you manipulate the gantries using force only one side of the gantries, you're just gonna get your axes out of skew. Um, you're gonna get them all skewed, which is obviously not good. That hurts the dimensional accuracy that this printer's capable of, and yeah, it just adds binding and just it's just across the board a bad thing. So that was the main thing that we needed to get rid of here, is basically just have the bearings directly attached to the base plate so that they are constrained to 90 degrees of one another. So if we just get rid of all these, yeah. Now this is the new tool head. Looks a little different. So the way it's constructed is basically you just have we still have a base plate to which everything mounts, except this time it includes these for the linear bearings. So these will always be constrained to 90 degrees from one another. Well, provided that the printer I print this base plate on isn't skewed itself. Then we these are just screwed down to the top here. I went with this with these straight walls here because I just thought that my reasoning is kind of stupid. I just kind of was worried that if I tried to print the actual radius of the bearing, that if it's not a perfect fit, it will create a not very rigid mounting for the bearings. I just figured that I just felt that this would provide a better, more consistent, predictable mounting surface. And I mean, I've got it already in the machine. It's fine. Yeah. Anyway, then we're keeping much of the same hardware from the first version of the toolhead. We're using same 4028 fan with new fan ducts, which yeah, I named very fittingly new fan ducts. They're not shit because these ones are actually I modeled properly so that the clearances are all good. If we look at the old fan ducts, you'll see that they're just kind of cut off at the bottom here, and that's because I just made a mistake while modeling, and I ordered them to be SLA nylon printed before checking if there was actually clearance. And so only after that part arrived did I have to shave off the bottom like this, because otherwise the nozzle couldn't have touched the bed. It's stupid, but you know, that's just a mistake I made. But this time the fan ducts are actually properly modeled so that they got all the clearances needed. Then for the extruder, we're using the orbiter again. And then for hot end, we're using the Rapido X, which technically hasn't been released yet. I'm using a beta testing unit, which is I'm very happy that Fate has sent me that. It's a fantastic hot end. I'm really liking it, and so I'm using it here, of course. Then yeah, obviously 4010 fan. We're still using beacon probe, and you might be able to notice that the beacon mount is the last thing that I designed because it's just kind of very bodged together. I'm mounting it using these two, I'm calling them branches. Essentially, I was just very limited with options here because these rods were in the way, everything was in the way, so I had to kind of have these two very awkward mounts branches here. I mean, it works. I'm not sure how stiff it's going to be. Yeah, because you don't actually need you don't need to use an accelerometer to get usable input shaping results. You can just do manual tests and you'll get results that are perfectly acceptable for normal printing. You're not going to be setting speed world records or anything, but it's still usable. So, if I can't use the beacon for input shaping, big deal. Its primary utility here is a bed probe. Anyway, I probably didn't do a very good job explaining exactly some of my rationales behind the toolhead, but yes. I think that these should provide good. Honestly, the biggest change here that I think will have the biggest effect on print quality is just the belt fastening, because when you, on this kind of printer, you have four separate belt loops having to work in unity to move your tool head, and if the tension is not exactly the same, if the length of the belt is not exactly the same, that's going to have a negative effect on your printing. And this belt fastening system actually enables me to have even tension and length for the belts, and I just didn't have that before. So yeah. um yeah, anyway, let's get back to the actual physical printer. That's enough of me rambling for today. Okay, we are fast forwarding in time a little bit, but everything is now assembled. It's on the machine, it's working, it's printing. I didn't film the assembly process for this because I didn't do it all in one session. I did it just in multiple small sessions throughout the week, so it was just a bit of a faff to film. But yeah, it all came together, and it all came together quite well. I did not really have any issues installing it. The most tricky thing about it was maybe like the press fits for the square M3 nuts. Those were a bit tighter than I wanted them to be, but that's really not a big deal. I didn't have to reprint anything or make any big changes, or there weren't any disasters like there have been for previous upgrades. Um, yeah, it all came together pretty well, and honestly, I'm quite happy. Um, it's it hasn't fixed everything. There, in fact, it hasn't really fixed the problem I wanted it to fix, but we'll speak about that more when we just switch perspectives in a second. But yeah, just looks wise, that certainly looks a lot better. Having these belts fastened in this way just looks, it's just so much nicer than it was on the last version. Um, and also okay, cable management isn't perfect yet, but it's certainly a lot better than it was before. This looks at least somewhat intentional. It's just a little bit more tidy. Maybe I should probably cover this with something black, but the cable chain and everything looks a lot better, and also the clearances for the cable chain are better, so that when I've got the lid on top of this machine, you know, it doesn't push the lid off when you go into certain positions. That's not the case anymore. Nothing's catching on a tool head like it was before. So just looks wise, is much, much, much better. I think it's just a much prettier tool head. Looks a lot more intentionally designed, looks a lot more thought out. And yeah, let's just switch to my face on desk cam, and then we'll speak about what the problems of this were. Okay, now having had these updates now for a couple weeks, I've been able to do some test prints. I've been able to put some hours on the machine to see if quality is improved, and unfortunately, not really. We still have pretty persistent VFAs. I'll put some pictures on screen of some stuff I've printed, but the VFAs are still there. And they're not particularly predictable. Well, no, they are. That's a lie. It's just kind of hard to manage them because the main cause for VFAs on this machine is just low speeds. And the problem is you can't really avoid low speeds. You might basically, once you get above like 200 millimeters a second, VFAs start to go away. The problem is Um, that's really only useful if you're traveling in straight lines along the axes. With the way cross gantry Cartesian kinematics work, even if you were to set all of your speeds to 1,000 millimeters a second, if you're going shallow enough of an angle relative to the axes, at least one of your axes is going to be moving much slower than the threshold for good surface quality. Um, so, you know, and this is apparent on the VFA tests as well. If you're going in a straight line, it's great. But the moment you start moving diagonally or start, having some big shallow radiuses in there, um, one of your axes is going to slow down and it's going to be below that level that is required for good surface quality. And that's just quite annoying. Now, there are definitely some improvements with this new toolhead and new gantries. Like obviously, just it looks nicer. It just looks like a more polished package. But also practically, uh, the part cooling's better from the fan ducts. The fan ducts are much better. The belt mounting is now such that all the belts are the same length and they're mounted evenly. So you're going to have more synchronized. Your axis is going to be a bit more synchronized now. And also, it's just a bit stiffer. Um, the beacon mount, like I mentioned, might happen. The the beacon mount itself isn't quite stiff enough to give really good, accurate input shaping graphs. But just from doing manual tests, um, the, uh, everything's a lot stiffer now. It's before my input shape values were like 35 for each axis, and now they're in the high 50s. So I'd say that's an improvement. That's around like what 20 hertz stiffer. Um, but yeah, I mean those things really are just those weren't the things that we were really targeting. We wanted to deal with the surface quality, and we haven't achieved that, which is unfortunate. But I think this at least I think this has shown me that what we really need to do is change these motors. I think maybe the specific NEMA 23s I'm using are just not very good. I'm using LDO NEMA 23s that I bought from the Rat Rig website a couple of years ago. But that just I've tried all sorts. I've tried a large range of currents. I've tried 24, 36, and 48 volts. Um, I've tried a number of like driver tuning settings, and I just none of them really have an impact on the surface quality. I think that just they're they just I don't quite understand it, but the way I think about it is that they're just when you have motors with very high rotor inertia and also pretty high torque, when you switch between steps, you're really just slamming between steps really, really quickly and just really aggressively like hitting the next step. And that just creates a really jittery, uneven motion. Um, there's probably like a much more scientific explanation, but that's just kind of the way I've been visualizing is that they basically are too high torque, so they're just slamming in between steps with basically no resistance, and that's just causing my VFA. I think I'm not sure, but I think that NEMA 23s are just not the way to go for this machine. Um, the moving mass just it's by no way a light it's by no means a lightweight machine, but the moving mass is just too high. The moving mass is just not high enough to justify having NEMA 23s. So I'm going to be switching to NEMA 17s. That's what's on screen right now. Yeah. So I've already redesigned the motor towers for this. I'll be using long shaft NEMA 17s. I'm just going to be using the basic ones available on Stepper Online initially, and then if they work, I'll probably order the Max NEMA the Max NEMA 17s from um, Excited 3D, because those are the best performing ones. But I'll just stick with the cheaper Stepper Online ones first. But it's quite a similar concept. I basically just shrunk down the motor towers a little bit, you know, cut off this corner to make it look nicer, in my opinion. And also, I'm using larger bearings to support the motor shaft because the ones I'm using at the moment are just, I think, a little undersized, and I'm hearing a little bit of squeaking during printing. And then the idler on the other side also uses these bigger bearings for live idlers. Up until now, I've been using just regular idlers, and they're also just a little, I think, a little bit squeaky. So I'm going to be switching to live idlers, just a full pulley with an ejector pin going through it, sitting in two slightly larger bearings. I think these are 19 diameter, 6 millimeter height, and then a 5 millimeter inner diameter. And also, I just positioned them to be a little bit closer to the edge of the motor tower, just to cut down on total belt length as much as possible, just to, maximize stiffness, maximize responsiveness. And then also, I've opted to not have belt tensioning inside the motor tower itself. That just created a headache when trying to, install your belts. And also, I don't think it was quite stiff enough. I think that there was a bit of play in the tensioning mechanism that I was using before. And with it being, like, basically buried inside the motor tower, it's kind of hard to check that kind of thing and, like, keep tabs on how it's holding up. So what I'm going to opt for is something that I have used on the much larger cross gantry printer I've built. I'll image on screen. It's basically a belt tensioning system where the tensioner is separate to the motor tower. I haven't fully finished designing it yet, but you can kind of get the vibe here. It's just a live idler that's, it's in a little, that fits into a groove and slides back and forth. And I'll probably use a fine pitch thread as well, and like a proper nice big turning handle, so I don't have to use one of these to tension. Yeah, so obviously I haven't actually printed anything out here yet. This is just what the next steps are going to be. I don't really have a timeline on this because this all costs money. I don't have any. Yeah. It's a bit frustrating that this last change didn't really bring the quality improvements that we were looking for. After spending money on parts and filament, for it to just kind of not work is a little bit demotivating, but that's the hobby. Spend money and maybe get results. Yeah. I'll try and make another video once I get to the actual build process of these new motor towers with these NEMA 17s, but I don't really have a timeline on that. Anyway, even though these upgrades weren't exactly successful, I hope that I can at least provide some insights on the realities of trying to do these kind of projects when you don't have the ideal technical knowledge or background. Sometimes things just don't work. Um, not every upgrade will work, and that's just kind of something you have to accept at some point. Yeah, anyway, I hope you've at least found this this process interesting. I certainly have. I haven't particularly enjoyed it, but found it interesting. um, yeah. Anyway, yeah. Maybe in the next couple of weeks I'll have another update video on the motor towers. Anyway, thanks for watching. If you have any questions, please leave a comments. Yep. Thanks.